Deep in the cosmic darkness, 500 million light-years from Earth, something extraordinary defies our understanding of the universe. Every 16.35 days, like celestial clockwork, a mysterious radio signal erupts from space with mathematical precision that seems impossible for any natural phenomenon. This is FRB 180916.J0158 plus 65, one of the most enigmatic repeating fast radio bursts ever discovered. And it's forcing astronomers to confront a profound question that challenges everything we thought we knew about the cosmos. Why do some of the universe's most violent explosions follow perfect mathematical patterns? The discovery that revolutionized our understanding began with the Canadian Hydrogen Intensity Mapping Experiment, where astronomers observed something that shouldn't exist according to conventional cosmic physics. For 4 consecutive days, this distant source unleashes 1 or 2 radio bursts every hour, each blast releasing more energy in a millisecond than our sun produces in 3 days. Then, as if controlled by some cosmic timer, the source falls completely silent for exactly 12 days before the entire cycle repeats with mathematical perfection. This revelation shattered the prevailing assumption that fast radio bursts were chaotic, unpredictable events. When astronomers first detected these cosmic flashes in 2007, they appeared to be random explosions scattered throughout the universe without any discernible pattern. The discovery of the Lorimer burst, named after astrophysicist Duncan Lorimer, who found the first confirmed FRB, introduced us to signals that could release the energy equivalent of 500 million suns in the blink of an eye. Yet, the mathematical precision of repeating bursts like FRB 180916.J0158 plus 65 suggests something far more sophisticated than random stellar explosions. Recent breakthroughs from the James Webb Space Telescope have provided unprecedented insights into these cosmic mysteries. In 2025, astronomers achieved something previously thought impossible when they traced the brightest fast radio burst ever detected to its exact stellar source. Using Webb's infrared capabilities, researchers identified a powerful explosion from a large aging star system located 130 million light-years away, marking the first time scientists have resolved individual stars around an FRB source. This technological triumph has opened new pathways for understanding the precise stellar environments that birth these mathematically perfect cosmic signals. The mathematical patterns extend far beyond the famous 16-day cycle, FRB 121102. The first repeating burst ever discovered exhibits an even longer periodicity of approximately 157 to 160 days, with bursts clustering within specific active windows. More remarkably, scientists have discovered sub-second periodicities that challenge our understanding of cosmic timing mechanisms. FRB 20191221A displays a precise periodic separation of 216.8 milliseconds between its multiple components, while FRB 20201124A shows a newly discovered 1.7-second periodicity that emerged from over 2,800 detected bursts. The physics behind these mathematical patterns points toward some of the universe's most extreme objects. Leading astrophysicists propose that these periodicities emerge from binary systems containing neutron stars, the collapsed cores of massive stars, where a teaspoon of matter weighs as much as Mount Everest. In these cosmic laboratories, gravitational forces compress matter to densities so extreme that the very fabric of space-time becomes distorted. When a neutron star orbits a massive companion, the resulting gravitational dance creates precisely the kind of mathematical periodicity observed in repeating FRBs. The most compelling model involves a magnetar, a neutron star with magnetic fields 1 trillion times stronger than Earth's, locked in orbital embrace with a massive stellar companion. As these cosmic titans orbit each other, the magnetar's emission beam sweeps across space like a lighthouse, creating the observed periodic patterns. During the active phase, stellar wind from the companion star feeds material into the magnetar's magnetosphere, triggering the intense radio bursts. When the orbital geometry changes, recent discoveries from 2024 support this model, as astronomers detected a wobbling magnetar whose precession damped over several months, providing direct evidence that neutron stars can exhibit the kind of regular motions necessary to explain FRB periodicity. The mathematics of this precession follows precise physical laws, creating predictable patterns that match observations of repeating bursts. Perhaps the most mind-bending discovery emerged in 2024 with FRB 2024-0209A, which exhibits a possible 126-day periodicity, despite originating from the outskirts of a quiescent elliptical galaxy filled with ancient stars. This discovery challenges young progenitor models and instead points toward scenarios involving globular clusters or low-mass X-ray binaries, suggesting that the universe has multiple pathways for creating these mathematically perfect cosmic signals. The sudden activation of this source after years of silence hints at critical threshold events where binary systems reach configurations that trigger the FRB mechanism. The implications extend beyond individual burst sources to the fundamental nature of cosmic evolution. Analysis of repeating FRB event rates reveals that these mathematical patterns exceed the star formation rate at lower redshifts, suggesting that the mechanisms creating periodic bursts have evolved over cosmic time. This discovery connects FRB periodicity to the broader story of how the universe has changed since its formation, with different types of stellar environments producing different mathematical signatures in their radio emissions. Current observations push the boundaries of what we can detect and measure. The CHIME telescope system, with its 1,024 receivers scanning vast swaths of sky as Earth rotates, has detected over 1,000 bursts from individual repeating sources without finding underlying short-term periodicity, suggesting that the long-term mathematical patterns represent a different class of physical phenomenon entirely. Meanwhile, facilities like the 500-meter Aperture Spherical Telescope, FAST, in China have detected dozens of bursts from single sources within days, providing the statistical foundation necessary to identify subtle periodic patterns. The search for mathematical patterns in FRBs has revealed an unexpected diversity of cosmic clocks. Beyond the well-known 16-day and 157-day cycles, astronomers have identified potential periodicities ranging from seconds to hundreds of days, each pointing toward different physical mechanisms operating in extreme gravitational environments. Some patterns manifest in the bursts themselves, others in the rotation measure variations that track changes in the magnetic environment around the source, creating a complex symphony of mathematical relationships that encode information about conditions in the most extreme regions of the universe. These discoveries force us to confront fundamental questions about cosmic order and chaos. The existence of mathematically perfect patterns in some of the universe's most violent events suggests that even in extreme environments, physical laws create predictable structures. The periodicity observed in repeating FRBs represents a form of cosmic information, encoded in radio waves that have traveled billions of years to reach us, carrying mathematical signatures that reveal the hidden clockwork mechanisms operating around neutron stars and black holes. As we stand on the threshold of new discoveries, the mathematical patterns in fast radio bursts continue to challenge our understanding of cosmic physics. Future observations with next-generation radio telescopes will search for even more subtle periodicities, potentially revealing hierarchical patterns within patterns that could unlock the deepest secrets of neutron star physics. The universe, it seems, has embedded mathematical codes in its most energetic events, waiting for us to decipher the cosmic equations that govern the most extreme matter and energy in existence. The perfect mathematical patterns in repeating fast radio bursts represent more than just cosmic curiosities. They are direct glimpses into the fundamental clockwork of the universe itself, where gravity, magnetism, and exotic matter create cosmic timepieces that tick with the precision of atomic clocks across billions of years of cosmic time. Each burst carries within its mathematical structure a piece of the larger puzzle about how the universe operates at its most extreme limits, where the laws of physics create order from chaos and embed perfect mathematical relationships in the most violent cosmic phenomena we have ever discovered.